Hello students, in this video we'll prove the match-mismatch identity. This identity states, this is called match-mismatch. Okay. It says that if I sum over k, k goes from 1 to 3, epsilon I j k, epsilon r s k, what we'll get is we'll get the Kronecker symbol, delta I r, delta j s, minus delta I s, delta j r. Okay, so this is the match. In other words, what you do is you match the first entries, the I and the R, and the J and the S, and then you mismatch the I and the S and the J and the R. Match-mismatch. Now, to prove this match-mismatch identity, which is very, very useful in vector identities, remember we're summing over k in this identity, what we're going to do is we're going to use the fact that epsilon I j k, epsilon r s t is going to be the product of two determinants. This is going to be the determinant of what we get when we have a delta I, a delta j, and a delta k as my either columns or rows. And then I multiply that by the determinant of a matrix that has rows or columns, up to the right choice, delta r, delta s, and delta t. And one of these I'll choose to be rows, and the other matrix I'll choose to be columns. And so what we're going to get is we're going to get a determinant of a matrix. If I do operations, if I multiply these matrices together, so choose one to be the rows and one to be the columns, I'll get a delta IR, a delta IS, a delta IT, a delta JR, a delta JS, a delta JT, and a delta KR, a delta KS, and a delta KT. Okay? Now what I'm going to do is I'm going to do the match-mismatch identity. I'm going to sum up when I replace the t's with a k. So what we'll do now is we'll say epsilon I j k, and then epsilon r s k is going to be this determinant, the determinant of delta IR, delta IS, delta IK, delta JR, delta JS, delta JK, and then delta KR, delta KSK, KS, and delta KK. Okay? Now delta KK is always equal to 1. So if I expand this determinant along the rows, this is going to be a plus, this is going to be a minus, and this is going to be a plus. This is going to give me a delta IK. And then what subdeterminant? A delta JR, delta KS, minus delta KR, delta JS. I'll have a minus delta JK times what? Delta IR times delta KS. And then a delta KR minus delta IS, minus delta KR, delta IS. And finally, we'll have a plus delta KK, and then we'll have what? Then we'll have this subdeterminant delta IR, delta JS, and then a delta JR, and then a delta IS. Okay? Now, if I sum this expression over k, what's going to happen? Summing this expression over k, in this first term over here, when we sum over k, we're going to sum this over k. What will we get? We'll get the sum. K goes from 1 to 3 of epsilon I j k, epsilon r s k will be equal to what? Well, in this expression over here, all the k's will become i's. So what will happen is this will turn into a delta jr, delta is, minus delta ir, delta js for this first term over here. If we sum over k in this expression, all the j's become k's. So this will become what? Or all the k's will become j's rather. So this expression, this k will turn into a j, this k will turn into a j. And finally, what I'll get over here is I'm going to get 3 copies of this. So we'll get 3 copies of this expression, 3 copies of delta IR, delta JS minus delta JR, delta IS. Okay, we've got 3 copies of that. So what's going to happen over here? So let's look at the delta JR terms. I have a delta JR, delta IS. Over here I have a delta JR, delta IS with a plus sign, and I have 3 negative signs. So I get a total of 1 negative delta IS JR. 1 delta IS, delta JR. That takes care of those terms. And now I can look at the other terms. I can look at the delta IR, delta JS. I have a negative 1 over here. Then I have a negative 1 over here. Then I have a positive 3 over here. So I get a total of positive delta IR, delta JS. And this proves, this term is this term over here, that works, and this term is this term over here, it works out perfectly. So using the fact that the permutation symbol is the determinant of these basis vectors, delta 1, delta 2, and delta 3, we can use the Kronecker symbol to prove the match-mismatch identity. In future videos, we'll see how this identity can be used to prove other vector identities relatively quickly. Thank you very much.